What do burning wood, melting ice, exploding fireworks, and even the food you eat have in common? They are all part of a hidden energy exchange happening around us every single day. In the world of chemistry, reactions are not just about substances changing, they are about energy moving. And today, we uncover two powerful forces behind these changes: exothermic reactions and endothermic reactions. Fire and ice, heat released, heat absorbed. Let's step inside the invisible world of energy. The word exothermic comes from two Greek words: exo, meaning outside, and thermi, meaning heat. An exothermic reaction is a chemical reaction that releases energy into its surroundings, usually in the form of heat, and sometimes light. When wood burns in a fire, energy stored in chemical bonds is released. That warmth you feel near a campfire, that is energy being transferred from the reaction to you. Let's understand this scientifically. In every chemical reaction, bonds between atoms break and new bonds form. Breaking bonds requires energy. Forming bonds releases energy. If more energy is released when new bonds form than is used to break old bonds, the reaction gives off extra energy. That extra energy escapes as heat. That is exothermic. Examples of exothermic reactions: combustion, like burning wood or fuel; respiration, yes, even inside your body; neutralization reactions, when an acid reacts with a base. Every time you breathe, your cells perform a chemical reaction called cellular respiration. Glucose reacts with oxygen, releasing energy that your body uses to function. You are, in a controlled way, performing an exothermic reaction right now. Without exothermic reactions, life would not be possible. Now let's switch from fire to frost. The word endothermic comes from endo, meaning inside, and thermi, meaning heat. An endothermic reaction is a chemical reaction that absorbs energy from its surroundings. Instead of releasing heat, it takes heat in. When you place an instant cold pack on an injury, it becomes cold because the chemical reaction inside is absorbing heat from your skin. The reaction is pulling energy inward. Examples of endothermic reactions: photosynthesis, plants absorbing sunlight to make food; melting ice; evaporation of water. Think about plants. In photosynthesis, plants absorb sunlight and use that energy to convert carbon dioxide and water into glucose. Sunlight is not just light, it is energy. Without endothermic reactions like photosynthesis, there would be no food chain, no oxygen, no life as we know it. In a way, exothermic and endothermic reactions balance the planet. Chemists often represent these reactions using an energy profile diagram. On the vertical axis, energy. On the horizontal axis, progress of reaction. In an exothermic reaction, the energy of the products is lower than the reactants. Energy has been released. In an endothermic reaction, the products have higher energy than the reactants. Energy has been absorbed. But there's something important in both cases: activation energy. Even exothermic reactions need a small amount of energy to get started. A match must be struck before wood burns. That initial push is called activation energy. Once started, exothermic reactions continue on their own because they release energy. Endothermic reactions, however, require continuous energy supply. Understanding these reactions helps scientists design safer fuels, develop medicines, create energy-efficient systems, and understand climate change. When fossil fuels burn, they release massive amounts of energy and carbon dioxide. When plants absorb carbon dioxide during photosynthesis, they perform an endothermic reaction that helps balance the atmosphere. Even cooking is chemistry. Boiling water is endothermic. Burning gas on the stove is exothermic. Energy is constantly flowing between systems. Chemistry is not just in laboratories. It is in your kitchen, your lungs, and the sunlight above you. Exothermic reactions release energy. Endothermic reactions absorb energy. Together, they power the natural world. From the smallest cell in your body to the brightest star in the sky, energy is never created or destroyed. It is only transformed. And chemistry is the language that explains how. If you enjoyed this journey into the science of energy, don't forget to like, subscribe, and explore more with us, because curiosity is the spark that starts every reaction.